Okay, in the next video or two, we're going to do a quick look at time value of money, do a quick review, look at how to do many of these functions in Excel, because Excel is going to be a central part of this course. So we're just going to jump into looking at first present value, and I'm not going to really work through the equations, the formulas for figuring out the present value of a lump sum, etc. You can kind of look through this. What I want to jump to is how we're going to do this in Excel. So let me go ahead and bring up Excel. We're going to look at this first example here. What is the present value of $5,000 received 3 years from now with a discount rate of 8.25%. So we're going to look at and see how we would do that in Excel. This has the formula approach, not very useful or interesting. There's a slide here in a second that's going to show how to do that with a time value of money calculator. Again, that's not terribly helpful for this course. It's useful, it's correct, but I really want to help you develop skills in Excel. So I'm going to jump over to Excel real quick, and we're going to look at this first question and how we would do that in Excel. So again, the question is, what is the present value of $5,000 received 3 years from now if the required rate of return is 8.25%? So we're going to use the present value function, and it's the PV function in Excel. And you can see as I double click on this, I have several inputs that I need to give Excel. So the first one, and it tells me here, is the rate. So I'm going to put in the interest rate, and it's really a periodic interest rate, and this is an important concept to get your head around as we're doing these things in Excel. It's a periodic rate because as I look at my question here, or the problem, my periods are years. There's nothing that says that those are modified otherwise. There's nothing that says it talks about monthly cash flows or compounded monthly, etc. So my periodic rate is 8.25%. As I scroll over, it now tells me what, or asks me rather, what is my NPER? What is the number of periods that I'm dealing with? So in this question, that is clearly 3 years, 3 periods. The next little input is the PMT. That's a payment. It's a periodic payment, so something that's occurring every interval over time. And in this particular case, there are no cash flows. All we're doing is we have this big lump sum at the end, $5,000, and we're trying to find out what that's worth today. So the payment is 0, and if I move over, we've got FV, that's the future value, and we're going to put in $5,000. Notice a couple of things here, that FV is in brackets. That means in Excel world that is an optional argument. You could get an answer without putting that in. In this particular case, it's going to be worthless because that's the only cash flow that we have in this question. So there's no answer that's going to be meaningful without putting in that input. The other input that's an option is this type. That's in brackets. And that's really a dummy variable. It's either going to be a 0 or a 1. 1 is the default, and that means that it's going to be an end of period cash flow. I might be saying that wrong. Yeah, 1 is the beginning of the period, 0 is the default, and that's end of period. So if we ignore it, Excel does what we want it to, and that's that it assumes that these cash flows occur at the end of periods. So that's going to be our default. We're never going to, I say never, I can't imagine right now a time where we would put in that type input. And again, it's understood to be a 0, so the only time you'd really type that in is to put in a 1. And that's whenever all these cash flows are occurring at beginnings of periods, and that's quite unusual. So we're going to leave that alone, and I get my answer here, and it's negative 3,941. One thing I want to point out is that if we change the sign of our cash flow to be a negative, it's going to change the sign of our answer to a positive number. So sometimes I'll play around with the signs in my arguments to get an answer that is of a sign that I kind of want it to be. This particular sign, the way you would interpret it, is that I would need to invest $3,941 today. I would have to write that check, so that's why we could see a negative cash flow here. We would have to invest that amount of money, and after 3 years of it earning 8.25%, it would turn into $5,000. I'm not going to get generally too worked up about the signs here, as long as you can interpret what's going on. So this is one way to do it in Excel. Just jam all the stuff into a PV formula. This is the method that I would prefer you do and how I would prefer you use Excel, and that is to kind of spell out all of the inputs for your problems, for your formula uses. And one thing that allows you to do is very easily change some of the inputs later on. So, and additionally, everybody can see what the inputs are. So this one is kind of hidden from view. You got to double click on it to see all the little pieces that are going into the calculation. But over here in this bottom area, everything is laid out. Everything is very explicit what we're doing. So the future value, that cash flow at the end is $5,000. The number of periods we're dealing with is 3. The periodic rate is 8.25%, and there's no payments. And so what I do when I calculate the present value this time, I'm still using that formula, still have all of these different pieces and parts, the rate, the number of periods, etc. But now I'm doing kind of what Excel is meant to do, and that's where I'm using cell references to do my calculation. So the first input is the rate, so I click on the cell that has the rate in it. So that's going to be cell C9, and I can just click over all of these things. So if I hit C9, hit comma, I'm moved over to the next argument. That's the number of periods. I click on the number of periods, hit a comma. Oop, that didn't work. Oh dear, what's going on here? Let's just start over. So present value, the rate is the first input. I'm going to hit a comma, go to the number of periods, hit a comma, go to the number of payments, click on that cell. Finally is future value, and I'm going to have to play a little trick here because my thing was covering it. So C7 is the future value. I close my parentheses, hit equals, or enter rather, and I get my answer. So very straightforward in Excel. This is kind of a little bit nicer in terms of etiquette. It lets everybody else see what you're doing and what's going into this present value calculation. Notice if I change this negative 5,000 here, or this 5,000 to a negative 5,000, it's going to change the sign of my answer, which again can be kind of helpful. I'm not having to go in here and mess with things. All of my inputs are spelled out right here. So I want to go back to the slideshow. We'll look at example 2. What is the present value of $5,000 received in 5 years with a required rate of return of 12%? Now we have something that's kind of modifying our assumptions. It says that it's discounted monthly. So we need to do some modifications. We need to have our periods be months and our periodic rate be a monthly rate. So let me go back to Excel and see how that's going to look. Again, $5,000, that doesn't change. But my periods have changed. So our periods are months. So we're asking the question, how many periods or how many months are there in 5 years? You can see down here that that is going to be 60. And if you look at my formula, I've got 5 years times 12 months per year. And so we got 60 periods. The periodic rate, I'm told that my annual rate is 12%. I'm going to discount that, or I'm going to discount that monthly, so I need to get a monthly rate. I'm going to divide that number by 12. So my periodic rate is 1%. And everything else is as it was before. Again, I prefer this method of calculation. So I've got my inputs, I use the present value formula, and I get an answer just like we did in the slideshow. Let's go on to the next slide here, and if we're dealing with, we've already done those calculations, if we're dealing with a series of lump sums, so we've got a series of cash flows occurring over time, we can use the present value function as well. Now it turns out that there's a better function to use, the NPV function. We're going to talk about that in a few minutes, but let me just show you, for example, how we would do this thing at the bottom. We've got a real estate asset that's going to give us $100,000 at the end of each year for 5 years, and then we're selling it for $725,000 at the end of the 5th year. So we've got a discount rate of 14.5%. What is the present value of those cash flows? Let's just talk through. This is the kind of the old-fashioned way of doing it here. We're going to use present value formula. We're dividing it by 1 plus the discount rate raised to the number of periods. Don't expect you to know that formula by heart. But we're taking $100,000, discounting it 1 period, the next $100,000, discounting it by 2 periods, etc. And our final answer is $720,000. Let's go to Excel and see how we would do that. Here are the cash flows, 100, 100, 100, 100. And then this is important. We're getting $100,000 from operations in year 5, but we're also selling the property. Oh dear. And I put in 750. Did I do the same thing? Oh, that's unfortunate. Yeah, either this should be changed to 750 or this should be changed to 725. I'm more inclined to change this number to 750 because we already got some answers, but we definitely want our numbers to match. Let's do it here and make that 750. I apologize for this little typo. So we're selling it for 750, and that's reflected here. We're collecting $100,000 from operations, and then we're selling it for $750,000 at the end of the year. So our total cash flow for the year is $850,000. Now what I've done in this column is figured out the present value of each of these cash flows, discounting them at the appropriate number of periods. I can add those all up and I get the right answer of $720,000. Alternatively, I can use the NPV function, so net present value. It's going to add up a series of cash flows that are discounted, and if I double click on this, I can see my first input or first argument is the periodic discount rate is 14.5%, and then I highlight all of my cash flows. We're going to talk more about the NPV function in the next video. I think I need to go ahead and stop now. We're already over about 11 minutes, so I want to stop, and we'll pick up with the next video, and we'll look at more at time value calculations and how to do those in Excel then. So I'll see you.